Section 6.2 covers the basics of probability. As we're building up to understanding what is statistically significant and how to calculate that, we also need to learn how to calculate some basic probabilities. Here are our learning goals. So when I conduct an experiment, the outcomes are the most basic possible results or observations. So for example, if I toss two coins, one possible outcome would be heads, tails, and the other one would be tails, heads. An event is a collection of one or more outcomes that share a property of interest. So for example, if I toss two coins and count the number of heads, the outcomes HT and TH are the same event of getting one head, or you could call that one tail. It depends whether you're looking for heads or tails. So let's consider a toss of two coins. And let's say we're only interested in the number of heads. How many possible outcomes do we have for a coin toss? Well, outcomes are each individual possible outcome. So we could have no heads, that'd be tail, tail. One head, tail, head. One head, head, tail. Two heads, head, head. Those are our four possible outcomes. But how many possible events could we have if we are considering the number of heads? Well, our events could be 0 heads, 1 head, or 2 heads. So there are 4 outcomes, but 2 possible events. When we express probability, that's going to be always between 0 and 1 inclusive. That means you can have a probability of exactly 0 or exactly 1. A probability of 0 means that the event is impossible. Most events have a really, really tiny probability of occurring. But for example, if the probability of flipping a coin and it landing on 6, or rolling a die and it landing on 7, because there isn't a 7 on die, that have a probability of 0. A probability of 1 means that the event is certain. So there's no way it could not occur. Theoretical probabilities are what we do when we are working with, for example, flipping a coin, rolling a die. So what we would do is we would count the total number of possible outcomes, and then all the ways that the possible outcomes, all the ways within our possible outcomes that our event of interest could occur. And we calculate the probability. We'd call that P of A. We use capital letters to signify events or description, to be the number of ways that the A could occur out of our total number of outcomes. So let's look at an example, and let's go back to flipping a coin after we talk about the probability of an event not occurring. So the probability of an event A is P of A, then the probability that event does not occur is the probability of not A. And because A can occur or it cannot occur, it's kind of black or white in this situation, that the probability of A and the probability of not A is going to equal 1. We could also calculate that the probability of not A is 1 minus A using a little bit of algebra. Friendly reminder, the event not A is called the complement of the event, right? And sometimes the not is designated by a bar. So this is read A bar, and it also means not A. For example, flipping a coin, heads or not heads, right? So you either get heads or tails, that's it. That's your only options. So let's go back to our coin toss. Remember we had 4 outcomes and 3 possible events of 0 heads, 1 head, or 2 heads. So for problem 1, it says, what's the probability we get only tails? Well, the only way to get tails is 1. So the probability of only tails would be the number of ways to get only tails out of the total number of outcomes. So that would be 1 out of 4, so 1/4 or 0.25 if you want to convert it to a decimal. I, out of habit, leave things as fractions, but if you convert them to a decimal, that's totally okay. For problem 2, what's the probability to get one head? Well, the probability of one head, that can occur 2 different ways. Tails, heads, or heads, tails. So that'd be 2 out of 4, which is 1/2 or 0.25. If you're going to leave it as a fraction, please simplify. Last, what's the probability to get one head or 2 heads? Or means both, right? So the probability of one head or 2 heads, either of those could occur. Well, there's 2 ways I could get one head, and 1 way I could get 2. So that would give me 3/4 or 0.75. Next, suppose we pick a person from a large group at a conference. What's the probability that the person selected has a birthday in July? Assume 365 days out of the year because leap year just screws everything up for everybody. So first, let's think about July. How many days are in July? Well, that's going to be 31 days. So if I pick a person at a conference, there's 31 different ways out of 365 days that they could have a birthday. So in July. So 31 out of 365 possibilities. That's how we calculate the probability that a randomly selected person has a birthday in July. And if you are a July birthday, you might make our case. This is about a 1 in 12 probability, which makes sense, right? Because they're 12 months out of the year. There's more than 12 people in this class. Someone's got to have a July birthday. Let me know. Next, we need to talk about counting outcomes. Suppose A has A possible outcomes and B has B possible outcomes. Then, assuming the outcomes of the processes do not affect each other, so they're independent, like flipping a coin and rolling a die, the total number of different outcomes for the two processes would be the number of times A could occur and the number of outcomes in B. So number of outcomes in A times the number of outcomes in B. This can extend to any number of processes. I could roll 20 die. Okay, that'd be a lot. I could flip 2 coins. I could flip 7 coins, right? We could figure out the total number of outcomes by multiplying the possible outcomes together. So how many outcomes are there if you roll 2 fair die? Well, when I roll 1 die, there's 1 possible outcome. If I roll another die, there's 6 possible outcomes. If I roll another die, there's 6 possible outcomes. So if I roll 2 die, there are 36 possible outcomes. Next, what's the probability of rolling 2 ones when 2 fair dice are rolled? Well, if I'm rolling 2 dice, there's only one way to roll 2 ones. Each of those dice would have to roll a 1. So that's me 1 out of 36.